guys. So yesterday, that we had started with the complexes. I told you about the complexes. A complex consists of a central metal ion surrounded by the ligands through dative bond. Okay. And then I told you about the ligands. Ligand, that is any species which has the lone pair of electron and has the ability to form dative bond. Okay. Uh, so today, my dear students, we are going to start with the types of ligands. Okay, so let's start with the types of ligands. So we got three types of the ligand. The first one that is called as the monodentate ligand. Okay, the second one that is called as the bidentate ligand. And the third one that is called as the uh, polydentate ligand. Okay, so these are the three different kinds of the ligands. Now, one by one, we are going to discuss each of them in detail. Okay, so let's start first of all with the monodentate ligand. Okay, so the first one that is the monodentate ligand. Okay, so monodentate, as the name indicate, mono mean one or dentate mean dative bond. So a ligand which can form only one dative bond with a central metal ion, that is called as the monodentate ligand. Okay, so a ligand which can form one dative bond with central metal ion is called monodentate ligand. Okay. The examples of the monodentate ligand, that is water, H2O, the oxygen of the water, it can form only one dative bond. The second example, that is the ammonia, NH3. This one can form one dative bond. The next example, that is Cl minus, it can form one dative bond. The next example, that is Cn minus, it can form one dative bond. So all these are the monodentate ligands. Okay, they can form one dative bond with the central metal ion. I'm going to take an example of the water. So let's take a copper, that is +2. Okay, so what would happen? The water that is going to form the dative bond with the copper, and I told you normally the six ligands they attach. Six, four, or two ligands they normally attach. Okay, so we got the six water molecules and acting as a ligand attached to the copper. So the oxygen of the water that would attach. So you should write like that. So oxygen of the water. Okay, so the oxygen of the water, 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 like that. Okay, now you know that water that is actually neutral. So the charge of this copper that would come on this whole species like that. Okay, so now if you look, every species is forming one dative bond with the central metal ion. Okay, so that is why this one is called as the monodentate ligand. Okay, so it can form one dative bond only with the central metal ion. Okay, now let's start with the bidentate ligand. Okay, so what is the bidentate ligand? A bidentate ligand, as the name indicates, bi mean two. This is the ligand which can form two dated bonds with the central metal ion. Okay, so a ligand which can form two dated bonds with the central metal ion. Okay, is called bidentate ligand. Okay, okay, my dear students. Now we are going to discuss about the examples. The two examples they are in your syllabus. The first one, that is, I'm going to write down the name first of all, ethyl 1,2-diamine. Okay, so ethyl 1,2-diamine. So it means you got the two carbon. So ethyl, two carbon, diamine. So NH2 is attached up here and NH2 that is attached up here. So this nitrogen can form dative bond. This nitrogen can form dative bond. So two dative bond could be formed. So this is number one. The second one, that is ethane di-OH ion. Okay. So what is this one? If you look up here, this is carbon. This is carbon. Double bond O, and this is O minus. This is O minus. Okay, so this is called as the ethane di-OH ion. Okay, so now we are going to make the ligand from them one by one. I'm going to make first of all for this one. If you look up here, copper is +2. Okay, so this is ethyl 1,2-diamine. So everybody just look up here, CH2, CH2. So this one is having NH2, NH2. So this nitrogen can form dative bond. This nitrogen can form dative bond like that. Okay, just like that, CH2 and CH2. So this one NH2 and NH2. So this one could form dative bond and this one could form dative bond. And just like that, CH2, CH2, NH2, NH2. So this one can form dative bond. This one can form dative bond. Okay. So this whole thing, if you see, that is neutral. It is not having any charge. So the charge of the plus copper. So this is copper, my dear. Okay. So copper +2 charge would come on this whole species. Okay, on this complex. So this is, if you see, the 6 dative bonds are formed and only 3 ligands they are involved. Why? Because this is the bidentate ligand. Every ligand can form 2 dative bonds. Okay, so 6 dative bonds they are being formed. If you make it with this one, so have a look up here. Copper is +2. Okay, so if you draw it like that, C double bond O, double bond O, O and O. So this one can form dative bond. This one can form dative bond. Now up here, C and C. Double bond O, double bond O. O, O. So this one can form dative bond. This one can form dative bond. Just like that, C and C. Double bond O, double bond O. So O and O. So this one can form dative bond. This one can form dative bond. Now, if you look up here, my dear, this one species is having negative one and negative one, negative two charge for one ethane diol type. So you got 1, 2, and 3. So times 3, so it would become -6. And copper has got the charge on it that is +2. So if you solve it, you will get the answer -4. So this whole thing that is having the charge -4 on it. Did you get it? Yes. Okay. Okay. The last one that is the polydentate ligand. The third one that is the polydentate ligand. Polydentate, as the name indicates, poly means many and dentate means dative bond. So, a ligand which can form many dative bond with the central metal ion, so that is called as the polydentate ligand. So, a ligand which can form two dative bonds with central metal ion is called polydentate ligand. Okay. The example of this polydentate ligand that is only one, and that is EDTA. Okay, EDTA. Now everybody stop writing and just listen to it. You as well, Uzair, Muskan, and Yaya, beta, please have a look up here. Because I'm going to write down the full name of this one and then drawing this particular ligand. So the word E comes from ethyl. So ethyl means the two carbons. So you should draw the two carbons up here, CH2 and CH2. Okay. The second thing that is D. The D word comes from diamine. So diamine means the two nitrogen they are attached with it. The connection to दोनों भी same. किनकी बॉडी को उसकी बारे में किसकी पोलीडेंटेट की और बायोडेंटेट और पोली में भाई मैनी डेटिंग बॉन्ड है कोड नाम लिखा और गलती से क्यों लिख दिया यार फॉर्म मैनी गलती से वो लिखा है वो गलती उसको तो निकाल दे व्हाट्सएप ग्रुप जो है वो आगे से एक ही हफ्ते मार रहा है यार मैंने बताया कि ये पोली का मतलब मैनी है वो तो पता है तू बोलते कि सर आपने गलत लिख दिया है अच्छा जी okay so D for diamine so diamine ethyl diamine means that the nitrogen is attached with them the T word that comes from tetra means four so the two up here and two up here you know that nitrogen can form three bonds so one bond is already made so two bond it has to make so the A that comes from acetate. Okay, so the acetate means CH2, C double bond O and O minus. This is CH2, C double bond O and O minus. This is CH2, C double bond O and O minus. This is CH2, C double bond O and O minus. Okay, so this is the polydentate ligand. Now, if you look up here, it has got a lone pair up here, lone pair up here, lone pair from these two oxygens of negative and these oxygens of the negative. So it can form how much dative bonds? 6 dative bonds. 1, 2, 3, 4, 5, and 6. Okay. So if you got the copper plus 2 ion, let's suppose. Yes. Okay, so it can form dative bond. This nitrogen can form dative bond. This nitrogen can form dative bond. This oxygen can form dative bond. This oxygen can form dative bond. This oxygen can form dative bond, and this oxygen can form dative bond. Now, if you want to write down the charge on this whole species, so this is plus 2, minus 2, and this is minus 1, minus 2, minus 3, minus 4, minus 4. So if you solve it out, you will get minus 2 answers. So just rub these negative ions and rub this positive 2 ion, okay, and write down this whole species charge that is equal to minus 2. So this is, my dear, polydentate ligand. Everyone got it? Yes, sir. So now we are going to start the next thing. Basically, in some of the papers, what he do, he just wrote down the name of the complexes and wrote down the name of the you can say ligands. So how could you do them? Have a look up here. Naming ligands and complexes. Okay. First of all, my dear, water H2O, this is called as the aqua. When you want to write down the name for the ligand, okay, its name is aqua. The NH3, this is called as the amine. It's not ammonia, it's amine. Then OH minus, that is hydroxo. Oxy, oxo. Then Cl minus, that is chloro. Then Cn minus, that is called as the cyanone. Okay, and then Br minus, that is called as the bromine. Okay, now let's suppose I'm going to write down uh, a complex up here, chromium, water 6, and it got plus 3 charge on it. Okay, now everybody just listen, guys. Listen. You know that water that is neutral, the charge on chromium that is plus 3 and it would come up here. Now, if you want to write the name of this complex, we should start from the ligands. So this is 6 means hexa, okay, and water that is aqua. Hexa, aqua, this is chromium. We should write up here chromium. And then chromium got the plus 3 charge, so in brackets you should write 3, and then it is the positive charge, so this is cation. So the name of this whole complex, that is hexa, aqua, chromium, 3 cation. Did you get it? I'm going to write down one more for you: copper, water 2, and ammonia, they are 4, and it got plus 2 charge. Now, if we look up here, water is neutral, ammonia is neutral. So the charge of copper, that is plus 2. So you should write from here, this is tetra, ammonia, that is called as the amine. Okay, and this is di, aqua, and then copper. And in the bracket, we should write 2 and then cation. Okay, so this is tetra, amine, di, aqua, copper, 2 cation. Everyone got it, guys? Okay, guys. Now, what we are going to do, I'm going to write down the complexes of the copper up here. Okay, the complexes of the different metals, they are same, but the color is different. Okay, so what I'm going to say to you, I have a look up here. The complexes of copper. The first complex of the copper, it has got 6 water molecules in it and plus 2 charge on it. So this is having, this is actually the blue solution. Okay. So one more thing, anything which is having the charge on it plus 2, minus 4, minus 2, that thing always form the solution because it is soluble in water. Anything which is neutral, having no charge, So that thing will form the precipitate. Keep this thing in your mind. Okay. So the next thing, second thing, copper. You got water molecules four, OH there are two, and this whole thing that is neutral, and this one would form blue precipitate. Okay. The third one that is copper. With the copper you got the two water molecule and four ammonia, and this is having the plus two charge, and this one will form a deep blue solution. This complex could also be written like that: copper, the ammonia, there would be 6 and plus 2 charge. Okay, this one would also form the deep blue solution. So with copper, if all the ammonia are present, 6 ammonia are present or 4 ammonia are present with two water molecules. If you look 6, if you look up here, 4 and 2, 6. 2 and 4, 6. This is 6. So 6 ligands are normally attached to the copper. Okay. So this is the fourth one. The color of this 6 ammonia or 4 ammonia, that is exactly same. The last one, my dear, copper with Cl4 and negative 2 charge. So it will form the yellow solution. Okay. So you should memorize the complexes and the colors of this one. Now one more thing, what the work I'm going to give it to you. आप लोगों को मैं काम देने जा रहा हूं, and you people have to please search for it, because these complexes got these colors. Okay, so the different complexes, if you change this copper with the nickel, okay, only the nickel would change, the other things they are exactly same. Water 6 and plus 2 charge. Find out the color of this one, because I have no idea, मुझे याद नहीं है, मैं गलत नहीं बताऊंगा आपको, क्योंकि ये रट्टा है, मेरे जेल से निकल जाते हैं. Okay, then nickel with 2 water, sorry, 4 water, 2 OH. Okay, this is neutral, so this is having precipitate. What is the color of the precipitate? I have no idea. With nickel, so just replace the copper with the nickel, the color would be different. Okay, and just like that, at the place of nickel, you should write cobalt. Cobalt. Okay, and the colors. So nickel and cobalt colors, you should make the complex by your own and find out their colors, because we will do the questions inshallah tomorrow in the next class.